Welcome to another episode of Xa Talk Show. Today is 2019, November 29th, Friday, 10 o'clock, 10 after 10 in the morning, San Francisco time. And today's topic is JavaScript, live coding JavaScript plus tutorial, JavaScript and SVG. And we are going to do a check. Okay, so my sound stopped. Sorry about that. So today's topic is going to be JavaScript plus SVG, live coding plus tutorial. I'm going to explain what I'm doing, and we are going to code a real-time rotation of platonic solids. Now you hear. Okay, so great. So we are going to code live rotation, real-time rotation of platonic solids. And I did two videos before. But if you want to start from scratch, check out the previous video about 3 days ago on my YouTube channel. So good morning, Benjamin. Good morning, Matt. So we got concurrent viewers too. Okay, so just you two guys. Well, okay. So let me mention thanks to this person, Brust, for donation. You can go to I have my PayPal and Patreon on my website xali.info. So let's begin coding, shall we? Okay, so let's start coding then. JavaScript. Let's start to code JavaScript. So I'm going to start command log mod. So on the left window you see all my Emacs commands, and actually let me magnify my font. Okay, let me do some Emacs setup. New buffer, Menlo 15 on the Mac. Evaluate it. That's good. So Benjamin, Matt, you do some JavaScript, right? Benjamin, do you code JavaScript? So let me get this ready, okay? Today is Friday, so today is kind of relaxed day. Yesterday is Thanksgiving. Oh, today is Black Friday, shopping day. So close that and talk show live stream. That's right, and we are going to do JavaScript. Okay, some JavaScript you've done. Okay. So today we are going to do polyhedron real-time rotation, okay? And okay, let's continue with that JavaScript live rotation. Let's show this in Chrome. Okay, this is not working for some reason. Abdul. Good morning, Abdul. Good morning to Egypt, I believe, right? Okay, so we're gonna going to do some JavaScript. Okay, let's I need to get started to warm up and get on the track. So first of all, let's look at this one. Chrome, showing Chrome. Okay, we're gonna start with that one. That one's got some problems, and we are going to also, let me prepare some code here. So we need more code here, and what we need is what is this? Okay, so go to Sadi blog and Sadro and index showing Chrome browser and open that polyhedron rotate. Okay, so this one, so we're gonna do some JavaScript. Good morning, Alan. Cairo, Egypt, yes. And good morning, Alan, to sunny California. Okay, so we're gonna do JavaScript. I need to get on track. So what are we doing today? So we are going to basically improve this one. You see, this one is kind of screwed. The colors is not right. It's kind of transparent, but it's not. You see this effect. It's actually a bug. So we're gonna make it a solid, so you don't see the part behind it. Okay, that's the first thing we're gonna do. Let's just focus on that, shall we? Let's just focus on this one. And that one doesn't work for some reason. I have like so many versions right now. Um, so copy that, close that, create a new window, paste it here. So we're gonna fix this one. So, and which one is this? Okay, so this one is right here. So again, for those of you new here, there is another video a few days ago. I did 2 videos before, but watch the second one because that one start from scratch. That one is 1 hour and 50 minutes, which we arrived at this state where we have icosahedron or octahedron or dodecahedron and octahedron and cube and tetrahedron. Okay. Okay, so we need to go back to icosahedron. Go back to icosahedron and oh my god, coding. I should get prepared, but okay. Let's take it. Let's just take it easy and go do whatever. If we cannot finish, then we cannot finish. So what's up, you guys? Have you guys eaten turkey? Okay, first of all, let's fix the faces. Why is it like that? I don't know. So I think I have to explain. Live coding, and also explaining what's going on is not so easy. Basically, you have to choose something you know well, then you do it. You don't go into places you don't know well, because otherwise you're gonna think for 10 minutes, then code just for 1 minute, and nobody wants to watch that. So you want to pick something you know well already, and like know it so well you can just start to code fast. But the other issue is that when you do live coding, you have to do explanation at the same time. So if you are coding by yourself, you can just type away, but oftentimes you have to explain. and the explanation will take like 50%, more than 50% of the time, because when you coding, there's so many. Maybe you made a typo. Even if you made a typo, you have to explain it, because otherwise, because most people will not know what, because you are doing it, you know it, but other people don't. So what are we doing now? So we are trying to fix this. So in order to fix this, there are 280 lines of code. So we did this before, so I'm not going to explain. I'm not going to explain, but where is the problem? Well, I know where is the problem. Okay, that the problem is around when you generate a SVG face. So let's see. So we have here fill. We are using a transparency here. You see this RGB. That part is transparent because of the last value. Now this is, by the way, same syntax as CSS. So if we take away fill, cut, and let's just say yellow, refresh, then you can see the problem. Now it becomes really funky. Yeah, that's an interesting thing that's going on. The reason that's happening because right now the code. Okay, let me show you a different version. Okay, instead of yellow, here is the line. Okay, comment that out, and wait, undo, undo, undo. Okay, so copy the line, then comment this out, then in here we say yellow. Okay, that's the current version we have. Copy the line, paste it again, comment out the yellow, and let's say fill none. Okay, refresh. Now that's better. That's wireframe. You see, they are rotating in only one direction. Let's see. It's hard to tell which direction they are rotating. But now, if we say fill yellow, refresh, then we get this kind of funky thing. The reason that happens is that we are drawing each of these polygon in a plane. Some are in front of the others. But how can I explain this? This is very disorienting to see. Code first, explain after. Oh, okay, yeah. So code first, explain after. That seems a good advice. Code first, explain later. Yeah. Okay. So, but what are we doing? What am I doing? So what I need to fix this. I know I know what is wrong. That's what we can do is going to, you see, we have the polyhedron data here. So let me show you. Yeah, even I myself am confused actually. I don't know what am I doing. I should have really, yeah, every time I start to do this, I thought I should have done this before, like just to review it so I can do a better video. But every time I started to this is not too hard, and I thought it'll just work, whatever problems we can just explain and do it, live. But when I actually start to do it, there are like several minutes delay. Like I don't know, like I have to read the code and think about it. Okay, so anyway, so here is the icosahedron data. It might be interesting to see what happens to the other polyhedron. Okay, so here is octahedron, really funky. Let's see if you guys can see it. You guys can see it, right? So let's go to the HTML. Let's remove that, okay? Now it's better. So that's icosahedron. Now dodecahedron. It's really funky. Now octahedron cube. Okay, that's a good question. Animals. That's a good question. So that question gets us started. Thank you for asking that. So for we what we are drawing right now is platonic solids. So basically, they are convex solids. That means that it's like a ball. Okay, so it's not concave. It there's no dent. So everywhere it's like puffy. So when you have a convex solid, then it's really easy to determine which face is in front. All you have to do is you compute the center of a triangle. Let's see. Let's stop rotate. Okay. So you have this. Okay. This is really funky. This is this is. I'm trying to figure out why does this happen the way it is. Right now I don't understand, but I know I can understand it if I try to figure it out for 5 minutes. Try to think about it. Why does this happen right now currently? You see, but anyway, that's one topic. Okay, that's a very interesting topic to figure out why, you know, how it draws the way it is right now. Uh, that's very interesting. So that's one topic. And the other topic is right now we can just start to code. We can start to add proper code so that the face in front will hide the face behind it. So how do you do that? Let me explain. Okay, so remember there are two things we want to do. One is just to start to make it, how the algorithm should work. The other one is a curiosity, is to figure out what's the exact reason it is doing what it is doing right now. Okay, that's one question. We go back to that. But first of all, let's explain how to get it properly. So to determine which face in front, which one is in back, all you have to do is for each face you compute their center. Like a face has 3 points in three-dimensional space. So you compute their center, you got the center of the face. Then it's just a matter of seeing which of their z-axis has higher value. So the higher value for the z-axis, the z-coordinate, is more in front. That's very easy to do. Okay, so let's just do that first. Then maybe we come back to the curiosity. So to figure out the centroid, okay, here is the computation. So if suppose you have a triangle, so let's say A1, A2, A3. So that's one coordinate of a triangle, and let's see. A, B, C. Okay, so now we have 3 points of a triangle. It can be more. Okay, it doesn't matter. So let's add more. A, B, C, D. C to D. Okay, suppose we have anyway, you have a face, let's just say triangle. You have a face in 3 space, and each one is their coordinates a1, a2, a3, b1, b2, b3. And to compute the center, we need another point x1, x2, x3, such that this point is the center of that face. So the way you do it is very easy. This is what you do: a1 plus b1, b1 plus c1. You add them divided by 3 because there are 3 points total. So basically, you just average them. So here is what you do. So the new coordinate will be like that. Okay, so this is like the new coordinate. Let me show you. Okay, so this is a centroid. There's a math term, they call it centroid. Centroid, the center point among a bunch of points. So, and this works in any dimension and any number of points. So you can have more points. So if you have another point, let's say, okay, let me do it here. So that's one thing. Here is one thing. And now we have another thing. So in this example, in the second example, we have 4 points in space. And if you want to find their center, this is all you have to do. You just basically just average them. Wait, A, B, C, D. Okay, so this is gonna be A, B, C. Oh yeah, plus D. So this is gonna be like that. Does that make sense? The centroid, guys, make sense? This is called the centroid. Okay, so now let's go back. Let's write a function that takes a bunch of points and returns the centroid. So, but in fact, we have that code here already. So let me try to find it. So does that make sense? Amanos, let me know. If you can answer, that would be great. So because I know, oh, I did something, good. I answered the question. So let's get the centroid. Okay, so the code for centroid is this one. It's so simple. So here's the code for centroid. So get centroid, then you give it a bunch of vectors, arrays. Then it returns the centroid of a list of points. So that's very simple code. So let's put that code into our polyhedron. Here. So let's put a function where? Where do we put it? Let's say here. Okay, well, let's say above. Okay, here. Okay, get centroid. So centroid is a arrow function. It takes a list of points, and then it applies reduce. It takes any 2 points, a, b, c, and x, y, z. Then it computes a plus x, b plus y, c plus z. Okay, then it does a map. It divided by number of points. Okay, so anyway, so we got the centroid. Right, guys? Right? Let's see if I'm. 24 minutes. Okay, so this is this is not going so good. Centroid, we are not going to get anywhere with this speed. So now we have a centroid. Now we want to look at the code where it renders. Okay, so render. Hello Xa, hello Fitch. I not doing good here, and every time I think, I'll just stop. But if I stop, that's not going to work because if I stop now, then what's not next? Either we switch to some random topic uh, or next day tomorrow we're gonna do this again. So I need to do this anyway. So centroid. So okay, what am I gonna do with centroid? Okay, so let me go methodological by logically step by step. So I got a centroid function which returns the center point of a bunch of a point. In our case, it returns the center of a face. Okay, it returns the center of a face. Now, what do I want to do next? What I want to do is when I try to draw this thing, you try to find the centroid for each face before you draw it. You find the center point. Then check if that center point is on one side of the plane, xy plane. So when you do SVG, here's your plane. This is x, vertical is y. So this plane is xy plane. So I got a centroid of a face somewhere in 3 space. All I want to do is I want to find out if that point is on one side of the plane, because this thing we are drawing is centered on 0, on the origin. So if it's on one side, then draw it. If it's on the other side, don't draw it. That solves the problem. Okay, so the next step is to find where is the part that draws the polygons. So that would be in render. Okay, so render, it says face indexes. For each you append child, create SVG face. Okay, so for each face you now I know what to do. So here it is trying to, for each face, it creates a SVG element, then it draws. So now we don't want to do that for all faces. We want to do that only when the face is on one side of the XY plane. Okay, that's very easy to do. So we're gonna modify this line here. Okay, so if something else something. Okay, so if on one side of face, so if get centroid, we need a bunch of points for the face. But how do we get the points of the face? Well, it's somewhere here. Okay, it's somewhere here. Get face, there it is. So get face j returns a array. Each element is coordinate of a vertex of the face number j. Okay, that's what we want. Now go back to where we are here. So get centroid, we're gonna call it. Okay, we're gonna call it, and we're gonna call it with We're gonna call it like that. Call get face. Okay, call get face. J. Okay, so far so good. Even so far so not good. You are stuck with me. So get centroid, get face J. So get face returns a bunch of points. Then get centroid returns the centroid of that bunch of points. Then we take the z-axis. We take the z coordinate. Okay, so which is the second index, because remember we have a get centroid returns a point, and this point is in 3 space, so it has 3 coordinates x, y, z. So the last part is index 2. So if the z coordinate is greater than 0, then you draw it. Okay, then we want to draw it. Okay, so if that, draw. Else don't do anything. Okay, let's see. Okay, let's try that. Okay, wait. Yeah, let's try what happens with this. Okay, motive myself. So okay, so let's refresh. Oops. Okay. Okay. So I'm cooking pizza this morning, and I'm inviting my roommates to eat pizza. They are heading off to work now. So what is the problem? Uncaught type error. God. I'm not sure I'm gonna. This is getting very bad. 6 people watching. Are you guys still getting anything? Okay, so let me see what's going on. So uncaught. Okay, so stop rotation. When this keeps going. So what's this problem? PTS reduce is not a function. What? Okay, maybe our centroid, get centroid face. Oh, I know where it's wrong. I got it wrong. The syntax is wrong, so it should be here. Yeah. So you see, get face, then we have get centroid, then take the z coordinate. Okay, then if it's greater than 0, then draw it. Now let's try it. Yay! Yay! Problem. Good morning, Lyle Cardo. What is the problem? Yeah, indeed, we got a problem, but I I don't know why is it drawing like that. But however, you can see now. Look at that picture carefully. You can see that our algorithm is actually working correctly. But we got some other problems. For example, we got this blank thing there. I don't know why is it blank. I know why it's that like that, because yeah, actually I know. Um, it is like that because our data for our icosahedron is incorrect. You see, we have the data here for icosahedron. So here are the vertices, and here are the faces. I know it's incorrect because this data is given to me, this code, by my friend mathematician Herman. And he told me this is incorrect because he has a new version. So if we just replace the data by a new version, it should work. So I guess that's, when you have, you see these vertices, these are just a bunch of numbers. GG is a number. The reason they are using GG is because it makes it easier to compute. You see, GG is defined in here. GG is actually the golden ratio. Now, when you need the vertices for a icosahedron, you need golden ratio. Okay, let's go there. Let's go to. Now, if I cannot do code well, I go to mathematics to explain something interesting. So, but this is indeed interesting because when you are trying to draw a icosahedron or any polyhedron, you need a list of coordinates. Now, for a cube, the coordinates are easy to come by because it's just 1, 1, 1 or 1, -1. It's a variation of 1. But when you have something like icosahedron, the vertices is you have to compute them. And if you have not studied it, you may find this actually a very good problem in geometry. That is to find the coordinates for this thing by yourself. You can try to do it. Try to find the coordinates of all the coordinates by yourself. Or it takes. I mean, the problem is that you have a solid such that every face is a triangle. Well, more than that, but anyway, you go to Wikipedia, you look up these things, you will know what's going on. So anyway, the problem is to find all the vertices, the coordinates. Okay, that's a geometry problem. And it turns out, it's very interesting. It turns out there's an easy way to get them. Now, okay, they don't have it here. No, there it is. You see this image? This image is the key to find the coordinates for the icosahedron. Okay, so but this is not the version I want, but it is a key, but it is not the picture I'm looking for. Okay, since I cannot find a picture, actually I do have a picture. So you search for Xali Math Wonder. XA's top 10 math wonders. This article I wrote back in 2010 about, I'm trying to pick the top 10 most interesting, wonderful things in math. So I just picked some of them. So here's a fractal. Here is a constants, golden ratio. Here is a picture I want to show you. Open image. So you can see this image is pretty much, this image was from Wikipedia, but now they changed it to something more, less interesting. They changed it to this thing, less intuitive. But anyway, basically the two are kind of the same thing, you can see. So when you have this, so first, to find the vertices of this icosahedron, all you have to do is you get this rectangle first. So you get these three of these rectangle, then you intersect them in orthogonal way. Then the vertices will be the vertices on the icosahedron. Okay, so this is one This is the best way to remember to calculate the vertices of the icosahedron. Any comments, questions? Type it, okay? Uh, keep 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 the things going. So how do you? So what is this rectangle? This rectangle is a golden rectangle. This rectangle. Now, how do you remember golden rectangle? That's very beautiful. Okay. So you want to find a rectangle that looks like that. I mean, it's called golden rectangle. And golden rectangle, basically, if you look at my window, if you look at the black part of my screen, a golden rectangle looks something like that, this proportion. So your job is to find, so what is the ratio? So if the side is 1, what is the width? Okay, so how do you find that? So this is also very specific and very interesting. You find it by the ratio, okay, W over H is such that let's see how I can explain. It's such that, okay, if you take the height and if you draw a rectangle, I mean a square with the same height, then you will cut this rectangle into two sections. You see this section and this section. And the ratio of these two sections will be exactly identical to the ratio of the width and height. Okay? do I make sense? Um, well, I'm not sure I do. Golden. But you go now. You go to Wikipedia. I think you can read it. And okay, they don't have that. Oh, there it is. Golden rectangle. Okay, they do have a explanation. There it is. You see, golden rectangle is a specific rectangle in with a specific ratio of the width and height, such that such that well, just like the picture showed, wait, such that the ratio of the height and width is equal to the ratio of A and B here. If you make a rectangle, I mean, if you make a square out of the rectangle, so it's kind of self-referential. It's kind of the definition. You can think of it that way. And Wikipedia shows you many ways to construct to derive the number. So you can find out exactly what is A plus B. A plus B, it turns out it's a golden ratio. It's this number, 1.618, and so on. So that's, this is a very beautiful thing in math, okay, golden ratio and golden rectangle. And so once you have that, once you have this ratio of the rectangle, then you just put 3 of them together like that. Then you know the vertices of a icosahedron. Okay, hi Nabi. Nabi, you are late. So let's continue to. Okay, so anyway, so that's kind of a side point about how do you find the vertices of the icosahedron. Now let's go back to our code. So that's why you see. So we have icosahedron vertices here. You see, we have like how many of them? I don't know how many of them. 12 or 20. Let's see. 12 of them. 12 vertices. And you can see they are computed by GG. GG is the golden ratio. Okay, so you go up here. You can see this formula is this number is golden ratio. Okay, so that's how we get the vertices of a icosahedron. And the face, now how are the face computed? The face just the face data here, they are just indexes of the vertices. So for example here 0, 1, 4 means the zeros face, I mean the zeros vertex connected to the first vertex connected to the fourth vertex. So 0, 1, 2, 3, 4. So connect to this one. So that's what these 0, 1, 4 mean. And similar for the others. So that's the data structure for the face. Now, the reason our code is incorrect like that is because I believe it's because the face information is incorrect. That is why we get that funky thing. So to fix that, I believe we have a version that with the correct face. So let's use it. Okay. Let's use it. Okay, that's what we want. This code. Copy it, close it, make a backup. Now let's paste it. Okay, undo. Oh yeah, obviously it's incorrect because you see here we don't have enough faces. Okay, let's do that again. So here, how many faces in a icosahedron? Does anyone know? We can see 20, but however, we only have 12 here, so obviously that's incorrect. We got 20 faces. That's why we see these holes. Okay, now I know, and now I understand. Okay, go back. We want to copy, close that. So we're gonna delete this. Okay, now back to 20, correct. Refresh. Perfect. Perfect. Oh God. Now this is great. Now I guess we can say at least I did something for today. Oh my God, get this fixed. Now you see, that's one shot. You know, we fixed two things. We fixed our previous code that's missing faces, and we also fixed the problem of hiding the face behind. Okay, so let's add another feature. Okay, let's add a checkbox that says whether you want it wireframe or not. Okay, and let's do that. And let's see, do we have time enough to do something else? Let's make it 1 hour. Okay, let's make it 1 hour. Right now we got 10 more minutes to do. Let's not. Okay, so now we add a checkbox so that we can choose wireframe or not. Front-end programmer happy solution. Lose face by ending stream early. I was thinking ending stream early, but that's no solution because then what I'm gonna do? And tomorrow it's the same thing. The spice must flow. Okay. See you later, Matt. So we're gonna do. Let's do checkbox. Okay. Let's go to JavaScript blog, and let's go to my tutorial DOM. And the DOM, how do you do a checkbox? Here it is. So you do a checkbox by copying that, magnify. So go back here, go to the HTML page, don't save. So go to the HTML page, put a checkbox here, and checkbox wireframe, okay, ID wireframe, type checkbox, name wireframe, value, value checkbox wireframe. Actually, no value, okay. Then for wireframe, whoops. So we name it wireframe checkbox, okay, and show in browser. Okay, so show in browser, refresh. We got a wireframe checkbox. Right now it does not do anything. So now we need to go to our code, go to it, and go to the top and write. Now we can write this easily because this is not math. Okay. Wait. Document get element by ID and wireframe checkbox. Okay, we got the checkbox. Now we need to do something with the checkbox. So we do that by going to the bottom and add a event. So this will be like that. Wireframe checkbox, add event listener, input, and toggle wireframe. Okay, let's say toggle wireframe. So when people check this wireframe checkbox, it will toggle. It will call this function toggle wireframe. So what does that function do? Well, I don't know. Let's look at toggle auto rotation. So copy this, search for that. Okay, so that is the function for toggle auto rotation. Okay, hold on a second. Let's make a copy of that. Rename it toggle wireframe. Okay, and then if toggle wireframe, okay, hold on a second. If go to the bottom, if wireframe checkbox is checked, then rotate timer. Okay, we don't want rotate timer. What is going on here? It's just so basically if it's checked, then do something else, do something. Okay, so if wireframe checkbox is checked, okay, I know what to do. Then you say wireframe style, let's say a string. Okay, field none. Okay, you say field style. Okay, that's what you say, field style. So if the checkbox is checked, wireframe is checked, then you draw the polygon and the field is none. Otherwise, else field equals to red. Okay, let's just say that. Okay, so we added a new constant field style here. So let's go to the top and add a constant field style. Okay, so we need the field style. Then we need to go to the place where it tries to draw here, and it will just add field style. Not yellow, but like that. Okay. So here is we are creating a polygon, SVG polygon in that line. Then we add the attribute where is the coordinates for the polygon. Then we add a style to it. Okay, and let's double check one more thing. So toggle wireframe. So if that, then we need to call render. Okay, because every time user toggles wireframe, we have to render it. So actually, let's shrink this. Lisp style, code formatting Lisp style. None of the C style crap. Okay, if else render. If this do that, else do that, field style, then we render it. Okay, let's hope everything is good. When it's good, we can all go home. Oh yeah. Let's check wireframe. Oops. Uncaught type error assigned to constant variable. Of course, I know that. Shut up. You see, we have a constant field style. It actually should be not constant because we are changing it. So refresh. Click on wireframe. Okay, now this is another interesting side effect, visual side effect. The reason we see it like that because the field color and the edge color are the same. So we got that. So we don't want red. Field. Let's go to field again. Blue. Okay. Refresh. Click on wireframe. Now it's beautiful. Oh my god, this is beautiful. And in fact, we got it reversed. Oh wait, wireframe, no wireframe. Oh yeah, this is beautiful. We got the problem solved, guys. So should we have actually we it's 1 hour. I think that's it. Or should we do more? What do you guys think? Okay, so Nabi has a suggestion. Nabi has a great suggestion to see the background, like transparency. So we can do that. So instead of field blue, we just use that transparent colors. Okay, so let's search for RGB. So we just do this instead. Okay, so field, instead of a blue, we say that. Okay, so here is the part. Field, we give it a CSS color syntax. Okay, let's refresh. Okay, refresh. Now no wireframe. Oh, okay, I know what's going on too because remember our algorithm is not drawing anything behind at all. Because remember, if the point is above the z-axis, we draw it. Otherwise, we don't draw it at all. So it's not drawing anything behind it. So we need actually to draw it in order to see the, well, yeah, we can do that, but let's try it. Okay, let's go to the place where we call get centroid. Okay, here. You see, if if the centroid, okay, let me show let's make this easier. Okay, z coordinate, okay, equals to hold on a second. So constant z coordinate equals to get face, which is a bunch of points. Then we call get centroid returns 1 point. Then we get the last component, which is the z coordinate. Okay, so that's z coordinate. So now if z coordinate if is greater than 0, then we draw it. Okay, otherwise else, well, what we gonna do? So else we draw it too. Let's just do that now, but it doesn't matter. Okay. Okay, so we have that. We have that. But you see, this doesn't. We are using transparency. So what? So yeah, we can do this, but this is no different than just not having the if statement at all. For example, you see, instead of the if else, we can simply just draw it. It doesn't matter it's in front or not. We just draw it. We are just using the transparency. But since we do have the ability to find out which one is in front, then why don't we do something a bit fancy, such that if it's in front, it should have, let's see, more opaque color or something. What? So Nabi says if the wireframe box is checked, don't render. Yeah, that's what we did. Yeah, that's what we did. I that's what we did before. I think that's that's what we did. For example, if we comment this out and comment that out, so if z is greater than 0, then draw it. Otherwise, do nothing. So if we now refresh, you see, yeah, that I guess that's oh, okay. I think maybe that's it for today. I was planning to do some. Okay, let's see. Oh, so Nabi's suggestion is, yes, good point. So Nabi is saying if it's not wireframe, then you draw what is in front, but whatever is behind, you simply draw the wires, not the polygon. Okay, yeah, that's a good idea. So let's do that. So if it is in front, we draw it normally. Okay. Now, but if it's in the back, how do we do it? Okay, how do we do it? We have to change the field basically. But okay, so wait, so we need to add an argument to render. Okay. Now let's just hack our way through it. Instead of thinking of the proper way. So else, if it's not in front, then we just then field none. Yeah, it's easy to do. Field none. Okay. Right. So there. So if it's in front, draw it normally. But if it's in the back, make the field none. Let's try it. Refresh. Okay, click no wireframe. What? Oh, wow. Wow, the reason this happens is because it has no effect right now because the field style is a global variable. So once you set it here, it affects the part over there as well. Uh, so let's just do some more hack. Okay, let's just do some more hack. Let's see if that works. What? Um, okay, let's just do some more hack. I don't think it'll work because the field style is a global variable. So you actually need to put in the place where create SVG face there. So yeah, so it doesn't work because the field style is global. It just applies. Doesn't matter you. But as far as hack is concerned, we can try to hack it to make it work. So all we have to do is go to the create SVG face. Okay, we can kind of create a variable. Okay, we create a second variable here, x. Let's say field. Okay, let's say field x here. Okay, so I know what to do. We can finish this. Okay, we can finish this. No worry. Okay. We remove all that. We just create a SVG face here. Wait. Okay, we create SVG face and we go back to the create SVG face. Then we do our computing here. Get the z coordinate. If z coordinate is greater than 0, hold on a second. Yeah. So if z coordinate is greater than 0, we don't need that anymore. So if z coordinate is greater than 0, then what's going on? So oh, we already have that. Then we here, okay, we are hacking this code out of shape. So here, if z is greater than 0, then we set attribute. Okay, else I'm not sure this is going to work, but it's close. Let's just try it. Refresh. No wireframe. Yes, wireframe. It doesn't work. We cannot use global variables because this is global. Wait. Refresh. Oh, there it is. We are seeing something. This is another interesting effect. No wireframe. Wireframe doesn't matter. Oh, I know why. I kind of know why. Yeah, I think I know why. Because anyway, it's a bit complicated to explain. Yeah, I see. I know what you mean, Nabi, but uh, okay. Do we want to? I mean, the question is, should we do that? If we if we want to do that, I don't know how long it's gonna take. Because the code we have to. Right now, it's doing that because um, let's remove the global variable. Okay, let's just put the actual style here. See what happens. Okay. Refresh. Uh, no. Anyway, I think that's. I'm a hacker. Thank you. Okay, I think that's it. It's in 1 hour. Well, we did something. Now I wish I can go back to the code. I forgot to make a backup, so we cannot we cannot go back to the correct code we had before. Anyway, that's it for today. Thank you guys for watching. Bye guys. Close the video stream, end stream.